Jalaluddin, MCOM, delivered material about Swallow Home Automation System with Odoo at events at the Faculty of Engineering, Pancasila University, on Sunday, April 28, 2019. Pamulang University lecturer who runs a professional business in the field of ERP systems. Currently, he is the founder and CEO of Braintama. Master of Information Engineering Education. Completed education at STMIKERESHA in 2016. There are 4 industrial revolutions that have developed to date. First, mechanization, water power, steam power. Second, mass production, assembly line, electricity. Third, computer and automation. Fourth, cyber-physical system. Industry 4.0 is the name of the latest automation and data exchange trends in factory technology. This term includes cyber-physical systems, the Internet of Things, automasi, cloud computing, and cognitive computing. Interoperability, objects, machines, and people must be able to communicate via the Internet of Things and the Internet of People. This is the most essential principle that truly makes a factory smart. Virtualization. CPS, cyber-physical systems, must be able to simulate and create a virtual copy of the real world. CPS must also be able to monitor objects in the surrounding environment. Simply put, there should be a virtual copy of everything. Decentralization. CPS's ability to work independently. This makes room for customized products and problem solving. This also creates a more flexible environment for production. In case of failure or having conflicting goals, the issue is delegated to a higher level. However, even with such technology implemented, the need for quality assurance remains a necessity throughout the process. Real-time capabilities. A smart factory must be able to collect data in real time, store or analyze it, and make decisions according to new findings. This is not only limited to market research, but also internal processes, such as machine failures in production lines. Smart objects must be able to identify defects and delegate tasks to other operating machines. This also greatly contributes to production flexibility and optimization. Service orientation. Production must be customer-oriented. People and smart objects/devices must be able to connect efficiently over the internet to create products based on customer specifications. Modularity. In a dynamic market, smart factories' ability to adapt to new markets is critical. In a typical case, it may take a week for an average company to study the market and change its production. On the other hand, smart factories must be able to adapt quickly and smoothly to seasonal changes in market trends. Machine Interface System Model. The Machine Interface System Model is an integration concept between humans, software, and industrial machines to enable monitoring, control, and automation processes to run effectively and in real time. In modern industrial systems, the machine interface not only functions as a visual display, but also as a control center and operational data processing. The 3 main components in this model are SCADA, HMI, and Mekatronik systems, which are interconnected to form an integrated industrial control architecture. First, SCADA is a computer-based industrial monitoring and control system that is used to monitor and control processes remotely. This system is usually used in large-scale industries, such as power plants, manufacturing, water treatment, and the oil and gas industry. Second, HMI is an interface system that allows operators to interact directly with industrial machines or processes. HMI is usually a touchscreen connected to a PLC or control system. Third, mechatronics is the integration of mechanics, electronics, control systems, and computer technology in one integrated system. In the context of machine interfaces, mechatronics becomes the physical and systemic foundation of the entire automation process. The telecontrol system application with mechatronics is an industrial device control and monitoring system designed to enable real-time remote control of machines or processes. This system integrates mechanical technology, electronics, control systems, and communication software in one structured and interconnected unit. In its implementation, the telecontrol system not only functions as a monitoring tool, but also as a data-based decision-making system that is able to increase operational efficiency, safety, and reliability. Swallow's Nest Company uses Swallow Color Audio. The problem of Swallow's Nest entrepreneurs. First, Swallow's Nest theft. Second, room temperature is unstable. Coolness. Third, the income of Swallow Nest entrepreneurs is reduced. Tool solutions used for monitoring the Swallow house. First, anti-theft alarm. Second, Swallow calling sound. Third, room temperature control, spray. Fourth, Swallow house, CCTV. Fifth door lock system. Activate the anti-theft alarm by looking at the blue light.
Oke, modul sudah on ya, sudah mulai aktif untuk sistem SMS dan teleponnya. Kita tunggu saja sampai LED birunya off. Nah, ini sudah off. Jadi kita coba dengan memberikan cahaya menggunakan sensor ke dalam ruang inap. Jadi mendeteksi cahaya di dalam ruang inap. Apabila mendeteksi adanya
Test the
cahaya, maka LED
anti-theft
biru
alarm by
nanti
using a
akan
light that
menyala dan
shines into
melakukan
the swallow
panggilan
house.
telepon dan SMS ke nomor handphone. Kita coba ya.
Next,
Kita
it will be forwarded
berikan
via
cahaya ke
SMS to the
dalam
cell phone number.
ruang inapnya. Itu adalah ruang inapnya nih. Kita nyalakan dulu senternya. Nah, seperti ini. Kita perhatikan di sini pada LED indikator biru. Apabila nanti menyala warna biru, berarti mendeteksi cahaya dan akan melakukan panggilan telepon dan SMS ke nomor handphone pemiliknya. Nah, ini sudah mendeteksi adanya cahaya di dalam ruang inap, maka LED indikator biru akan menyala. Matikan senternya. Apabila pintu terbuka pada lubang antar lubang di ruang inapnya, pada saat pintunya terbuka, maka LED indikator pun juga akan menyala berwarna biru dan akan melakukan panggilan telepon dan juga mengirimkan SMS ke nomor handphone pemiliknya.
This alarm
Pada
will
saat
sound
pintu
when the
terbuka,
door is open.
maka alarm ini akan berbunyi. Ini pintu menuju ke ruang inapnya. Kita coba buka saja. Akan alarm berbunyi. Alarm terus berbunyi dan mengirimkan SMS. Nah, saya matikan. Sudah saya matikan. Oke, mungkin itu aja dulu ya. Review secara singkat yang mungkin bisa saya sampaikan mengenai sistem LDR, yaitu resistor peka cahaya yang mungkin bisa bermanfaat untuk sistem early warning atau sistem keamanan dalam sebuah bangunan gedung Walet. Sampai jumpa di lain kesempatan. Terima kasih.
A room temperature control device that functions to regulate indoor humidity. Swallow House CCTV, which is integrated via the internet network. Installed door lock device. To find out the log of doors being opened and closed, the Odoo Mechatronik's Telecontrol System application is an ERP-based integrated solution developed using the Odoo platform to support the management of remote control systems, telecontrol, in the mechatronics sector. This system is designed to connect monitoring processes, device control, project management, and financial management in one integrated platform. In its implementation, this application integrates main modules such as inventory, sales, purchase, manufacturing, project, and accounting to support telecontrol system operations involving electronic devices, control panels, sensors, actuators, and IoT or SCADA-based communication systems. The Swiftlet house control system automation uses: first, anti-theft sensor; second, swallow calling sound; third, room temperature control, spray; fourth, swallow house CCTV; fifth, system door lock. Telemetry system uses Raspberry Pi 3B Plus device, RAM 1 GB, quad-core processor, 32 GB SD memory, Bluetooth, Ethernet, USB, HDMI, and GPIO 40 pins. Odoo IoT application that controls door open and close. Raspberries that are installed at the Swallow House location can be remoted via the internet.
IoT dengan server backend-nya adalah menggunakan Odoo. Tampilannya di Odoo seperti ini. Jadi ada satu modul IoT, di mana modul ini digunakan untuk menyimpan data yang dikirim oleh device-device IoT yang ada di RBW di Sulawesi Tengah, dan data itu dikirim ke server ini Dan ini adalah hasil penyimpanan datanya seperti ini. Misalnya pintu besi, sensor pintu besi. Sensor ini akan mencatat event log berupa kapan pintu ini dibuka. Nah, ini nanti ke depan akan dikembangkan dengan event log ini. Ada aplikasi di mobile yang akan mengirim notif. Nah, untuk sementara belum sampai seperti itu. Sementara ini baru pencatatan data yang masuk dari sensor dicatat ke Odoo. Kemudian ada sensor DHT menggunakan DHT22 di lantai 1 untuk mencatat temperatur dan kelembaban. Nah, seperti ini. Untuk temperatur dia akan masuk ke telemetry log. Kalau tadi untuk pintu tipenya adalah event log. Nah, di telemetry log ini akan menerima data dari sensor setiap ini kurang lebih 3 menit. 3 menit Odoo akan mencatat data temperatur ini dan kelembabannya ini. Per 3 menit data akan dikirim oleh sensor dan akan dicatat di Odoo. Nah,
Thank you for listening to my presentation. See you again at Rumah Teknologi Prima with a discussion of different material. I'm Jalaluddin from Rumah Teknologi Prima.